Welcome back to our geometry series. Today we are up to section 7.3 where we'll be looking at the area of trapezoids. In our last section we looked at a parallelogram, which is a quadrilateral that has opposite sides that are parallel to each other. And we defined the height of the parallelogram as being the distance from the base to the top, and it's always perpendicular to the base. What if we sliced it in half like this, and left with a quadrilateral where only the top and the bottom were parallel with each other? This leaves us with a trapezoid. We still have a base, and we still have a height. However, we have this other distance at the top, which is now smaller, or different than the other base. So let's call the first one B1, and we'll call the other one B2. So a trapezoid has a height, but it has two different bases. So what is the area of a trapezoid? Well, that leads to theorem 85. The area of a trapezoid equals 1/2 the product of the sums of the bases and the height, or area equals 1/2 times B1 plus B2 times the height. So let's do an example with some numbers here. B1 is 17, B2 is 12, and the height is 8. So again, we use the same formula, 1/2 B1 plus B2 times the height, and we'll just substitute the numbers we have from the figure. 17 plus 12 is 29. So if we multiply by that 8, we get 232, and half of that is 116. Let's jump over to the whiteboard and do some quick examples. All right, we're going to go up here and draw a polygon. Now, I'm going to say it's a trapezoid. So just by looking at it, we should assume that two of the sides are parallel to each other. But I'm just going to draw it in just so we have it. So we know these are parallel. I'm also going to say that this is a right angle, and let's put some dimensions on here. 5, and the bottom here is 12, and the top is 7. What I'm going to do is up here in the corner, I'm going to write down the equation so we can use it. We know the area of a trapezoid is 1/2 of B1 plus B2 times the height. So here, the height would be something like this, right? But in this case, we already have a right angle over here. So this height and this side happen to be the same number. So if we wanted to, we could put the 5 down here. So the area here is going to equal 1/2 B1 is 12, plus B2 is 7, times the height, which is 5. So let's see here. Let's just do it one step at a time. 1/2 this plus this. That's 19 times 5. So we get equals 1/2 of 95. That's a little multiply there, which equals 47.5. And let's say that this was, inches. So this would be square inches. Next, we're going to draw another one down here like this. Let's say that this side over here, the angly part, is 13, and so is this one over here. And we'll define it as a trapezoid. So we have parallel sides here. When you have a trapezoid with these two sides like this being the same, this is what's called as an isosceles trapezoid. Let's throw in some other numbers here. We've got 22, and we've got 32. So again, the same equation applies, equals 1/2 times the bases and the height. Well, the bases here, 22 and 32. We can put that in. 22 plus 32. But what's the height? It's this distance here. Boop, 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 boop. It's perpendicular here. It's perpendicular there. So the other clue is that we have this part over here. So the base we can draw right from this corner, right? Like this, or like this, however we wanted to do it. So, because we have an isosceles trapezoid, this triangle here and this triangle here are going to be congruent. I mean, they're kind of flipped, but the sides and the angles will all be the same. So because this is 22, we know that from here to here is also 22. We've kind of created, a rectangle here. So if here to here is 22, but here to here is 32, we know that this has to be 5 and this has to be 5. So it looks a little confusing here. So really this 32, we could kind of say, nope, you're not 32 anymore. You're 22 from here to here. And then we had the 10 left over, 5 here and 5 here. It has to be split evenly because we know these two triangles are the same. So now we have this triangle. We know 5 from here to here and 13 from here to here. So you can use a Pythagorean theorem, or remember that 5, 12, and 13 make up a right triangle. So this is also 12. So if this is 12, then this is also 12. The height doesn't change no matter where you measure it from. So now you know the height of this is 12. So we can keep going here. 1/2 times 54 times 12, and that's 1/2 times 648. So then we're still on the screen, sort of. Half of 648 is 324. There's a good, happy answer. All right, let's clean this off and do a bonus problem. All right, we're going to do something a little funky here. I'm going to come up and over and down. So we have a quadrilateral, which does not look like a trapezoid. And then we're going to come down here and over like this. I'm going to start putting some dimensions on here. And what we're going to do is draw a little pretend line here, and one down from here, and one down from here. So these are all 90 degrees perpendicular to this kind of center line here. And let's put in some dimensions. So from here to here, this will be 4. The height of this one will be 5. Height of this one is 7. This is also 4. It's not drawn exactly correctly, but we'll just go with the numbers. This is 3 from here to here. This is 6. And this is 6. So the question is, what is the area of this now pentagon? Well, part of the trick here is that we're trying to find the area of this whole object, but we can cut it up into pieces. So what I see here is we've got a triangle here, we've got a triangle here, and here, and a triangle here. So what we're left with is this weird shape in the middle here. But the tricky part is that this line, this height, and this height are perpendicular to each other, right? So now this is a parallelogram. Nope, it's a trapezoid. Not a parallelogram, it's a trapezoid, because these are parallel with each other. So we can find the area of this triangle, this triangle, this triangle, this triangle, and this trapezoid, and we add them all up, we'll have the area of this pentagon. So what I'm going to do is kind of label these as 1, 2, 3, 4, and 5. And I think we've got enough room here. Smeary. So the area of number 1 is this triangle. And again, the area of a triangle, we'll just kind of cram it down here. Here's my pencil. So area of a triangle is just 1/2 base times height. So area of 1 is 1/2 the base of this triangle is 4 times the height, which is 5. So 4 times 5 is 20, and half of that is 10. So the area of triangle 1, area 1, is 10. Let's go over to 2. All right, so area 2 is 1/2 the base. So what is the base of this triangle? It's from here all the way to here. We know from here to here is 4, and here to here is 4. So the base of this triangle is 8, and the height is 6. So 6 times 8 is 48, and half of that is 24. So area 2 is 24. Let's go to 3 over here. 1/2 the base. The base is going to be this dimension here. So 3 and 6 together would be 9, and the height is 6. 6 times 9 is 54. That's 30. 27. I can do math. 27. Because 1/2 of 6 is 3, and 3 times 9 is 27. So 27. So area 3 is 27. So we've got this one so far, this one so far, and this one so far. Area 4 is another triangle. It's It's going to be 1/2 times the base. So here's triangle number 4. The base here is 6. And the height is 7. So 3 times 7 is 21. That's area 4 is 21. Okay, so now we have just the trapezoid left over. So the area of zone 5 is 1/2 times the sums of the bases times the height. So 1/2. So if we're looking at it, we kind of turn it sideways. Think of it. This is a base and this is a base, because the height of this trapezoid is really here. This is the height. You got to kind of imagine it turned 90 degrees. So base 1 is 5, base 2 is 7. So that would be 5 plus 7 times this height. So what is it from here to here? Well, here to here is 4, and here to here is 3. So the height is 7. 7. So 1/2 of 12 times 7. Okay, so half of this is 6, and that's 42. So area 5 is 42. Well, that's great, but we didn't look. Now we need to add all this up. So the total area, so area, I'll call it T, is, just add them all up. 10 plus 24 plus 27 plus 21 plus 42, and we'll go get Mr. Calculator. This equals 124. And let's pretend that all these measurements are in feet. So this would be square feet. Make sure you have your right units. So here we go. This is the total area of this oddball pentagon that we started with. That's it for today. We'll see you next time.